So given this inequality, x is greater than or equal to 3, we want to rewrite that and we want to graph it. Now I think sometimes it's easier to graph it out first to see what we're working with, and then rewrite it in terms of the other notation. Right? That's how we just reviewed the set notation and the interval notation anyway. So let's graph this out. Give yourself a number line. We're dealing in terms of x, so let's label it as x. On that number line, well, let's plop a 0 somewhere just for some perspective. And then the key value we're playing with here is 3, so 3 is obviously going to be to the right of 0. If it's greater than or equal to 3, we include the 3, right? So I put the dot. Greater than is going to be to the right, correct? I mean, which way is that arrow pointing? It's pointing to the right, so I must be going to the right here. If I shade everything to the right, I've got my graph. If I'm going to rewrite, though, the original problem in the opposite notation, so to speak, the interval notation for this would be 3, because that's the leftmost part of the region, and it would be included, so I need a bracket. And the rightmost part of the region would be infinite, so we go out to infinity, which we cannot contain, so I put parentheses. All right, same idea here on number 2. I'll give you an inequality statement. To be consistent, we'll graph it out, and then we'll go to the interval notation. So this time, -2 is less than x is less than or equal to 5. Set up the number line for the graph. Establish that it's in terms of x. Appreciation's sake, I throw the 0 on there. I look at the values I'm dealing with on the inequality. I got -2, I've got 5, so I'll put -2 over here in negative land, 5 over here in positive land. And when this x falls in between the two, I'm shading everything in between the two, right? Am I including the -2? It's open. Am I including the 5? I am, because of the equal to possibility. So we shade everything in between. There's the graph going to the so-called opposite notation here, the interval notation. If I'm going to draw this out in interval notation, I'm going from -2 leftmost to 5 rightmost. So -2, 5. -2 is not included since it's open, so parentheses. 5 is included since it's closed, bracket. So here we'll graph this one, but then we'll go the other direction with our answer. We're starting with interval notation. We want to put this in set notation. You throw the number line up there. If you want to spice things up and make this a little more interesting, you can pick a different variable, but I'm not very original. I like these x's. These x's have greater meaning to me later down the line in other math classes. So I'm sticking with the x's. I'm going to be stubborn about it. I stick my 0 on there. 3. We throw it out here. And when I see the interval notation of -infinity to 3, that tells me that 3 is not included. And I'm going from left to right here, so I'm shading everything up to that 3. Right, -infinity, leftmost idea, 3, rightmost idea. There's my left, there's my right. So using set notation, we're defining things in terms of x. So everything's going to be in terms of x. I throw my little bar in there. And then what's the inequality statement I'm going to use? X is less than, not equal to, 3. So there's your set notation. So given the union between these two intervals, can we come up with the set notation that represents that union? since all this stuff is connected to graphing somehow, let's be consistent and let's keep going back to these graphs. Assuming the graphs in terms of some x, we can get awfully colorful here. We mix this up a little bit. I'm going to let my first interval here be in red. So if I map out in red negative infinity to 0 on this number line, well, here's 0, and apparently that's included, right? Here's everything up to that point. So what you see in red here corresponds to this, right? Now you've got negative 3 to 8. We'll make that the blue piece here. So I should probably plop a negative 3 somewhere and an 8 somewhere. You go from negative 3 to 8, neither one of these is going to be included. So we open them both up. From negative 3 to 8, it's everything in between. All right, let's look at what we've ended up with now. We want the union. So the union means we want everything, right? All the stuff that overlaps between the two and everything else. So in this little section right here, this is all that overlaps between the two. But then this is another piece that we need to include. This is another piece that we need to include. Any idea what the interval notation, or sorry, the set notation rather, is going to be as our answer? You got your x that we're leaving everything in terms of. If I include all of this, I want this entire region, don't I? So that entire region is represented as everything up to 8, so that'd be everything that is less than 8. So x would have to be less than, not equal to, 8. So that's the union. Okay, so if we look at the opposite idea here and we do an intersection problem, in the interest of time here, let's stick with the same intervals. So negative infinity to 0 included, only this time it's intersecting with an interval of negative 3 to 8. We've already mapped out these two above. We know what the number line looks like. But when you take the intersection, you only want to take what is in common or overlapping between the two. So as you look at what I have here above, the red versus the blue, the overlap occurs right here. So since the overlap occurs right there and we're trying to write out the set notation, leaving things in terms of x, we're talking about a bunch of x values that fall between two other values of negative 3 and 0. I would start at negative 3. And I would say that negative 3 is, would it be less than or equal to x? It's just going to be less than because it's not included at negative 3. So less than x. And I'm going up to 0, so this is going to be less than or equal to 0. Which one is it? Less than or equal to 0. And there you go. There's the intersection. So go in the other direction. You're given the set notation. We're asked to find the union. It doesn't specify the notation that we need to leave everything in terms of at the end. But since we've got set given to us, let's use interval notation to express the answer. So A union B. If I'm going to find A union B, I would probably take a similar approach to what I did on the previous problems. Set up the number line. Because, hey, this graphing thing seems to be working for me. And on that number line, relating to set A, in set A, all the x's are greater than 5. So let's draw that out. You've got your 0. You've got your 5. Everything is greater than 5. And it's not included at 5, right? So open circle, greater than 5. For B, okay, for B, we've got a couple of key values of -2 and 7 to play with. So here's -2, here's 7. And if -2 is less than x is less than 7, we're shading everything in between there, not including the two values themselves. So open circle on -2, open circle on 7, shade everything in between. If you want the union, how am I going to express this in interval notation? The union takes in everything. If it was the intersection, like we talked about on the previous problem, we'd want the overlap here. Okay, the intersection would be from 5 to 7, not including either value. Right, that's where the overlap occurs, but we want the union, so we want everything else out here in addition to this intersection and everything out here as well. So what's my interval notation going to be? Where do I start? What's the leftmost part of that region? -2. And -2 is not included. How far can I go? You can keep going all the way out, right? So you can keep going out to infinity. The union of these two sets is -2 to infinity. If I had to do the intersection would be from 5 to 7. Make sense?